Okay, welcome back. So in the previous video, we talked about what the distributive property was, what its definition. The definition is that we can distribute what is on the outside of our group to each term inside of the group by multiplying, and we kind of proved it with this first example. So let's say we have problems, unlike the first examples, that have variables within them, and we don't know what those variables represent. We can simplify or rewrite the expressions by using the distributive property. So let's say we have 4 times the group x plus 6. Okay, so we don't know what x is equivalent to, so there's no way that we could simplify what's going on in this group. We can't really follow the rules of PEMDAS because we don't know what x is equal to, so there's no way to get one number on its own inside of this group. So we can rewrite this expression or simplify this expression by distributing the 4 to each term inside of the group. So if we do that by multiplying, this is going to be equivalent to 4 times x, which we can write 4x. Anytime we have a number right next to a variable like this, it means to multiply, plus 4 times 6. So I'm just going to write that out so you can see. But then if we simplify this even further, this is 4 times x plus 4 times 6 is 24. So this particular expression and this first expression, they are the same thing. This is just what we call in its expanded form. So let's say we have another example. Let's do the problem. Let's say we have 3 times x times the group x minus 1. Okay, so again, we don't know what x is equal to, but we can simplify this expression into its expanded form by distributing the 3x to both terms in the group. And you'll notice this time I have subtraction. So the symbol that's going to go in between my terms in my simplified expression is going to be a subtraction sign. So if I write this 3x times x, we could write that like this: 3x times x. Remember why we don't want to use the x sign for multiplication. It would get real confusing in this if we did that. So we could write 3x times x minus 3x times 1, which would just be 3x. Okay, now if we think back to our previous lesson about exponents, anytime we have repeated multiplication, we can rewrite that with an exponent. So 3x times x, we could also say that is 3x squared because we're multiplying x times itself twice. So we can rewrite this entire expression as 3x squared minus 3x. So this simplified expression and this simplified expression mean the same thing. We're going to do one more example just so you can see. This time I'm going to have a negative sign. So let's say I have negative 2 times the group 4 plus x. Okay, so what I'm going to do, like before, is I'm going to distribute this negative 2 by multiplying to each member of the group. So if I do this, negative 2 times positive 4 is negative 8. And now, before I automatically write my plus sign, or I can write my plus sign, I can do that. I'm going to distribute this negative 2 to x. And so the way that I'm going to write this is negative 2 times x, or negative 2x. So this is what it looks like here. Now I'm adding a negative, so I can keep it like this. Or I could also rewrite this problem like this. I could write negative x, or I'm sorry, not negative x, negative 8 minus 2x. These two mean the same thing. When we add a negative, it's the same as subtracting a positive. So all three of these expressions mean the same thing. This is just in the distributed form, and this is what's in its unsimplified form. So in the next video, we're going to talk about kind of going in the opposite direction. Like, what if we start out with these distributed forms? How can we put it back into what's called this factored form? So be on the lookout for how to kind of go backwards in the next two videos.